So far, in this development series, I've shown you how to get your development environment set up, how to work with the modeling language to create new participants, assets, transactions, and more within your Composer business network. And finally, I've shown you the permissioning language, which dictates how the different participants in the network can interact with the network. Now in this video, I'm going to be kind of tying everything together and walking you through the JavaScript API, which is the quote-unquote smart contract language that allows you to define the business logic within the network. And without these scripts, without these smart contracts within our network, it's dysfunctional. There's no point in having this network if we can't define the rules behind how the different participants, assets, transactions, etc. kind of interact with each other. So you can see I'm on the documentation page for Hyperledger Composer, and if we scroll down on this left sidebar to the API reference, this is kind of where we're going to be working out of. So I'll go ahead and click on that, and you can see a little blurb here. Now I'm going to point you to the original JS doc format because I believe this is a little bit easier to read through at the moment. I think that the Hyperledger Composer team is working on integrating this old format into this new documentation. So we'll go ahead and click on that and come over here. And this is a great way to get used to the JavaScript API and see how the different modules and classes work. Now, obviously in this video, I'm not going to be able to walk you through every little piece of this API, but hopefully I'll be able to point you towards the most important modules and classes and kind of walk you through writing some simple business logic within the network. I'll be working mainly in the Hyperledger Composer playground, as we have been doing in the past, and I'll be building on this perishable network that we've been working on already. Before getting into the actual code, I'd like to give a brief overview and a simple walkthrough of how you can create different business logic within your network. So right here in this video for text file, I've laid out the most common, or basically the classes and modules that we'll be working with in this video within the JavaScript API. Now if you come back to the documentation, you can see up here, if I click modules, there are 4 main modules that we can work with. And within these modules, there are several classes within each of them. On this text file, you can see that I've laid out all of these here. So we have the Composer Common, Composer Runtime, Composer Admin, and Composer Client. Now I'll first talk about these two. The Composer Admin we touched a lot on in the last video, and we're not going to be doing too much with it here because it's a lot to do with identity management rather than business logic. The Composer Client is the JavaScript API for basically executing a lot of the command line operations that we did also in the previous video, so we'll be kind of staying away from that as well. Now the Composer Common, from what I understand, represents a lot of base classes, stuff that we're not necessarily going to be touching, but what I want to bring your attention to is the Composer Runtime module, which has several classes in it that we're going to be using to interact with our business network and get all of the different information that we need to manipulate it. And within the Composer Runtime, there are just a couple classes that we'll be focusing mainly on, one being the factory class, and then 2 and 3 being the participant registry and asset registry. Don't worry if you don't understand this right now, but just get this in your head that this is what we're going to basically be working on today. So let's jump over to the playground because everything is going to be a lot easier to understand and explain here. Now, in order to create business logic within our network, there are actually several steps that we're going to have to take. And I'm going to walk you through those right now. We're not going to write a single line of JavaScript code per se, but it will give you the structure and the process for creating each new smart contract / business logic rule. So you can see right here, this is the perishable network that we've been working with so far in this development series. I've made a few changes that I will let you be aware of. The first one, as I alerted you in the last video, I went back to the default namespace just for simplicity. And also, right now, I've deleted the entire script file, or the logic.js, and just put a placeholder function in here that doesn't do anything. Last, I've gone over to the model file and deleted all the transactions that previously existed here. Now, we're going to create a transaction called the setup demo, which was already built into this perishable network. But we're going to rebuild it because at the moment, we don't have any participants or assets in the network. If we click on any of these tabs, there's nothing to show. We also don't have any transactions. If we try to submit one, we don't get any options here. So in order to create our setup demo, we have to first define it in our model file. So we'll come down to the very end of the model file and just give it a name. Start with saying that this is a transaction, and then we're going to say that this will be our setup demo. Give it some brackets, and that should be the correct syntax. So that's all we have to do in the model file. So we've let Composer know that we want to create this new transaction. Now, in order to actually do so, we have to come over to the script file. We'll delete this placeholder function because now we're going to have something. And this is not very apparent when you're first reading through the documentation, but you actually have to declare some parameters within the comment section before declaring a new business rule. So we'll go ahead and do that here, and I'll show you exactly how this works. So this first line of the comment, we start off by doing a backslash and 2 stars. Then we come down, put another star, and give a description to our smart contract or JavaScript logic. So this is just a setup demo. It will create new participants and assets automatically. Okay, so then we come down to the next line, put another star, and this is where it gets very important to understand. So you have to write it exactly like this. You have to give an @ symbol, type param for parameter, a bracket, give it the namespace that we are using, and then we need to refer to what we just created in the model file. So I believe we called it our setup demo, and close that off. So we've targeted the transaction that we created in our model file here via the namespace, and we've put this @param line. Then after this, we're going to declare what our function is actually called. So I'm going to call this the same exact thing as what we did in the model file, our setup demo. So you put that right here after the closed bracket, and then we can come down to the next line, and we have to say @transaction to let Composer know that we're creating a new transaction. So this is all of the necessary information that we have to put before actually writing our function. And then we can finally come down and say function, and we'll call it our setup demo. Actually, let's go ahead and put this in lowercase. Our setup demo, and we subsequently have to come up here to this line after the closed bracket and alter this because this is the name of our function. So put that to lowercase. So now this right here, the name of our function, and this declaration after we do the namespace is the same. So now we put our setup demo as a parameter for the function, and then we can actually write our function. And for the purpose of describing this process, I'm just going to copy paste it from the clipboard. If I can go grab that really quickly. Okay, so this should be the full function that we want to create. Get some spacing all right. Okay, and you can see everything looks good, so we'll update our business network. And just as a reminder, this is very important. This comment right here is what is telling this whole network, what this function is and how it relates to the model file that we just created, where we put the transaction our setup demo. So now we should be able to come over to test and submit a new transaction, our setup demo. And it's saying that setup demo is not defined. So we need to go work that out. Okay, so I worked out what was the problem here. So if you look down in the code that I had just copied in here, we're referring to setup demo, which is the old name of it. So we had called it our setup demo. So I need to update this to say our setup demo. Make sure that this isn't anywhere else. We'll update and then come over to test, and we should be able to now submit our setup demo. And you can see that we've now created a grower, importer, shipper, contract, and shipment. So that's the basic process of creating business rules for your network. And we're going to now be going through this sample network and walking through each line of JavaScript code and kind of pointing out different things that might help you building your own business network. Before we get too far into the code itself, I will mention that this is where things get on the coding side of the development series. So if you're not too familiar with JavaScript, just kind of bear with me here, because we're going to be talking about I'm going to be glossing over all of the basic JavaScript concepts. This is not a programming tutorial. And also, I'll touch on it a little bit, but you probably should have a good understanding of JavaScript promises before diving into this code, because a lot of the Hyperledger Composer JavaScript API deals with these promises to write these smart contracts. So let's jump over to the code editor. And this right here, you can see here that we have our entire perishable network that we've been working in as of late, which should resemble pretty much what we looked at over here in the playground. You can see that my logic.js file just has this simple setup, and for the perishable.cto, which is the model file, I have put in at the bottom, just like we did in the playground, the transaction our setup demo. So let's jump into the code. In order to create all of the different participants and assets, as you recall, if we came over to the test tab and submitted our setup demo transaction, what it did was create a new instance of the grower, importer, shipper, a new contract, and a new shipment, as seen over here. So that's what we're essentially trying to do with this function. So in order to do so, we have to actually create the grower, shipper, importer, contract, and shipment, and then somehow with a bunch of JavaScript promises, we're going to update the business network to reflect these newly created participants and assets. I chose this perishable network because the three quote-unquote smart contracts that we're going to be writing kind of touch on a lot of different aspects of the JavaScript API. Now in this our setup demo function, we're going to be dealing mainly with creating new resources to the network, new assets and new participants. In order to do that, before we do any of this coding, we need to create the factory. So we'll create a variable called factory, and we'll call the getFactory function. We will also declare a namespace, which should be familiar. This is org.acme.shipping.perishable. That's just so we don't have to rewrite it every time we have to use it. Now you're probably wondering, where does this getFactory come from? If we jump over to the notes, I had introduced the Composer Runtime module, and within that there is a getFactory, or actually it's a factory class. If we come over here to the documentation, the class is called factory, and we can use the getFactory method on that in order to instantiate this class. Then once we have that, we can use the different methods, the new concept, event, relationship, and resource on this factory class that we instantiated. So you can see that reflected here. So now what we're going to be doing is using this factory variable to create the different participants. Since we've already gone through the process of creating new participants and assets in the playground, this shouldn't be all that surprising on how we write the code to do so. So let's jump back to the playground and just remember what it takes to create a grower. So I've clicked on Participants, Grower, and Create New Participant. So we have to give this a class, which is just the grower, which was defined in our modeling file. We have to give it an email, farmer@email.com. We have to give it an address, which is actually a concept that we defined in the modeling file. And then finally, an account balance. So in order to translate that to code, we'll just come over and say var grower, so we create a grower variable, equals factory dot new resource. We'll pass in the namespace of our modeling file so that it has access to this grower term, and we'll give it the identified by field, which is the email for the grower. Now we're going to say grower address because we saw that we needed to add in the concept grower address, and we'll say factory.newConcept. We'll also give that in the namespace, and we'll say the name of it is address. And that should be all for there. And just to remind you, if we come over to the perishable.cto file, we've created this concept address already. So that's what I'm referring to here. Now that we've defined both of these variables, we can just add fields to them. So we can say, for instance, the grower address, which is a concept, dot country. Remember, the concept address has a non-optional country field, so we have to fill this in. So we'll say grower address dot country equals USA. Likewise, we can say grower dot address, and now we have to pass in this concept that we just created. So grower address. Finally, we have to give it the account balance. As you can remember, our grower, which extends business, requires an account balance. So we have to give that, and we'll give it an account balance of 0. So what we did in these 5 lines of code is essentially the same as creating a new participant right here. We're going to do that for the rest of the participants and then the contract and shipment assets. For the sake of time, since the grower, shipper, and importer all have the same model, we're just going to copy and paste these 5 lines of code down. So it creates the shipper and the importer. The only thing that we need to change is the participant that we're targeting. So we're going to call that shipper. We'll give it a different identifier, so shipper@email.com, and then Instead of grower down here, we'll say importer. So we'll say importer@email.com. I apologize, I almost forgot we have to also change the name of the variable itself because we're going to be adding them by their variable names. So this obviously is not a grower, it's a shipper, and we'll say shipper address. Okay, so these are all updated, and we have created the grower, shipper, and importer, and stored them in their respective grower, shipper, and importer variables. Okay, so now we have to build the contract. It follows the same exact process, and we're going to use the factory class that we created to do so. So we'll say var contract equals factory.newResource, just like we did for the participants. We'll pass in the namespace that we defined and the contract identifier. So if you remember, we called this asset a contract, and that's what that is targeting right there. Finally, we have to give it an identifier. So we'll say contract 001. And now we have to actually create the fields. So if you recall, when we went to create a new asset, we have to identify the grower, the shipper, and the importer. And if you look at our model file, all three of these fields are actually relationships. They point to some other model within this file. So in order to do that, we can use the new relationship method on factory. So we'll say contract.grower equals factory.newRelationship. And for this new relationship, what we have to specify is the namespace. We have to identify which participant we're targeting, so the grower. And finally, the identifier of the participant that we're targeting, which is farmer@email.com, right up here. So next, we can do the same for the other two participants. So we'll say contract.shipper, and we'll just copy this down. And then finally, contract.importer. And then we'll go ahead and edit this. So we're targeting the shipper here, the importer here, and then we need, obviously, their identifiers to create that relationship. Okay, so we have now created the relationships on the contract. Now we just have to fill in the rest of the fields. So the next one that we have to fill out is the arrival date time, which utilizes Hyperledger Composer's built-in date time module, which on every single transaction there's actually a dot timestamp class or method, whatever you want to call it, and we can specify that by saying tomorrow as a variable equals our setup demo dot timestamp. So when we create this setup demo, or actually we're going to want to go lowercase, so we're using this, which is the transaction, so our setup demo, and then that has a built-in timestamp, which is a date time syntax. So tomorrow equals whatever timestamp we get when we execute this transaction, but obviously that doesn't make any sense because that would be the current time. So what we have to do is use the JavaScript datetime built-in method to say tomorrow.setDate, and we'll give it tomorrow.getDate, and we'll add 1 to it. So basically what we're saying here is the arrival date time has to be 1 day after the contract. Once we do that, we can say contract dot arrival date time equals tomorrow, which is what we just created as a date time object. Finally, just fill in the simple remainders, which would be the unit price, min and max temp, and the penalty factors. So we'll say contract dot unit price equals 0.5, contract dot min temperature equals 2, contract dot max temperature equals, we'll say 10, and then the penalty factors is 0.2 and the max penalty factor is 0.1. Okay, so that should create the contract successfully. And finally, we have to create the shipment. And that works just the same as all the assets and participants above. So we'll create a variable for that shipment. We'll do so by saying factory.newResource, pass in the namespace, give it the shipment model identifier, and then the identifier for this particular shipment is going to be ship001. We'll say, and let's visualize this correctly, so we'll come over here to shipment, create new asset, and we can see that we need a shipment ID, which we already passed in. We need a type, which is one of our enums, a status, unit count, and the contract relationship that this asset is bound to. So let's say shipment dot type equals bananas, and if you can remember, in our model file we had defined this in the form of an enum, so the product type can only be one of those 5 options, and we chose bananas here. We'll say shipment dot status equals in transit, because when we first create this it's going to be in transit. And again, that is also an enum right here in our model file. Our shipment.unit count, so how many bananas are we shipping? We'll say 5,000. And then we have a relationship, so shipment.contract equals factory.newRelationship, give it the namespace. We'll say the type that we're targeting is a contract. And if you can see, we created our contract up here with an identifier of contract 001. So that's what's this shipment is going to have a relationship to. And there we have it. We have created the new shipment. So far, all that we have done is create participants and assets and stored them in their respective variables. But we haven't really committed this to the network. So like in any relational database, you obviously have to commit your changes to the database. You have to do this here as well. And the way we do this is via the JavaScript API using promises. So if we come over to the Composer documentation, let's go to the Composer runtime module, and we can see that we have the classes asset registry and participant registry. So both of these have the same exact function, just for the assets and then the participants. So you can see the asset registry has methods add all. You can check to see if an asset exists. You can get one or more assets. You can remove one or more assets, and you can update one or more assets. So this is the CRUD functionality, the create, read, update, and destroy functionality of our business network. And you can see that this works the exact same with the participant registry. If we click on that class within the Composer runtime module, we have all the same methods. So translated, actually before we get over there, let's look at the get participant registry method. So this is how we're going to get the existing registry of participants in our network. using a unique identifier of this particular participant registry. So in our case, that would be the .grower, .importer, or .shipper identifiers. And you can see that this getParticipantRegistry method is going to return a promise, which it'll basically return the registry itself that we can pass into another promise. So let's do this in the code. And this code gets pretty long, as we saw earlier, so I'll just give you the basic structure. Since we're in a function, our setup demo function, we can return something. So what we're going to return is a promise. And we'll use that getParticipantRegistry method from the Composer Runtime module. And what we do is pass in the namespace that targets a specific participant within our network. So for us, we could start with org.acme.shipping.perishable.grower or something like that. Now, an easier way to do that, since we've already defined the namespace, we can say ns for namespace plus and then .grower. That essentially translates to be the same exact thing. So we return the getParticipantRegistry, and then since this is a promise being returned, we can use a .then method, which comes with all promises, and we'll run a function where we pass in the grower registry into this function. So essentially, this return statement right here is going to return a promise that contains, if successful, it contains the grower registry, or the registry of all of the growers that we've created thus far. So now what we have to do, now that we've received that grower registry, we have to add the grower that we created right up here. We can do so by just copying the variable that we stored it in and returning it as grower registry right here, because this is a promise, and this promise has a method called addAll, and what we pass in there is an array of the participants or the growers that we're going to add to the network. So we just have grower, just one of them right now, and we can come over to the documentation and see that that this module, if we go to Composer Runtime, Participant Registry, and then this has the addAll method on it. So that's where we got that from. But we're not done here. We have to add the rest of the participants and the assets. So the next step is to drop down again and use another .then method, and we'll do an empty function that returns another registry. So we can use the same syntax, getParticipantRegistry, namespace plus, and then this time we're going to say .importer. So that's going to grab all of the importers from our network. And then, as we did before, we can pass that registry, if successful, as the importer registry, and drop that down. So now we can use the importer registry .addAll method and add the importer that we created up above. So you can see how this kind of follows a distinct pattern. We just do this until we get to the end. Now, it's a little bit different, but not much, to add an asset. All we would have to do is replace this getParticipantRegistry method with an getAssetRegistry method. And instead of .grower, we would say .contract. We'd come down here and say contract registry. We'd say contract registry.addAll and pass in the contract that we created right here and stored in the contract variable. So you can see how this will all work. I'm going to go ahead and complete this and not spend any more time on it. Okay, so you can see that I've completed this chain of promises. And as we just talked about, once I was finished adding all of the participants using the get participant registry method, I just came down here, and so I added my last participant, the shipper, with the .addAll method, and then in the next promise I returned get asset registry and targeted the contract. So you can see how that works. So this is a completed setup demo function. If we wanted to tweak it a little bit, since we have the addAll method, we could come up and say, hey, I want more than one grower created, so we'll copy this down and create 3 growers with this transaction. And then that should work if we just come down here and say grower, grower 2, and grower 3. So that should work. So what we're going to do, just to test it out, is copy this function and the comment that is absolutely necessary. We'll copy that over to the playground that we've been using, go to the logic file, and replace what we have here, and just see if it works. It's showing me that everything looks good. Let's make sure that these extra growers we had the correct syntax. Looks like it, so we'll press update. And then what we also have to do is, since we've already got these participants and assets in the network, it's not going to allow us to create another. So we'll go in here and alter that a little bit too. So we'll say farmer 1, farmer 2, farmer 3, shipper 1, importer 1. This will be contract 2. We'll include farmer 2 or farmer 1 on there, shipper 1 and importer 1, shipment number 2, contract number 2, and that should do it. So we'll update this, go over to the test tab, and what we're going to see, since we created 3 growers within our setup demo logic, we should end up with 4 separate growers. We should have 2 importers, 2 shippers, 2 contracts, and 2 shipments. So let's try it. Alright, so you can see we have 4 growers and 2 of the rest. So we successfully created this piece of logic. So far in our business network, the only logic that we have written so far is that one setup demo function, which all it does is create participants and assets. We don't have any of the functionality that we need to execute a temperature reading or a shipment received that uses this contract and shipment asset to create the basic functionality behind our network. So we have to go back to the perishable.cto model file, and we're going to create an abstract transaction definition. We'll call this shipment transaction. And off of this abstract transaction, we'll actually build 2 separate transactions that will correspond to 2 separate functions. And with both of them, we need to refer to a shipment. So the first one will be a transaction called temperature reading, and we saw this, I believe, in the second video in action. So temperature reading, and this extends our abstract transaction called shipment transaction. So we'll say extends shipment transaction. Okay, and so by default, in order to execute this transaction, we need to provide it the shipment that we're going to put into this transaction. We also need to put in a temperature reading, because that's what we're doing, is reading the temperature. So now that we have defined this, let's remember what we called it. So we'll copy this to the clipboard, temperature reading, and we have to create a new function. So I'm going to go ahead and go to the bottom of our logic.js file, and we will create this new function. We first have to make the comment that is going to tell the whole file system what this function refers to, and we'll say, give it a description, so a temperature reading on one of the perishable shipments. We'll give it a parameter, which remember that is a namespace, so org.acme.shipping.perishable, and we're referring to the temperature reading transaction, which we just defined, temperature reading. Finally, we have to tell it what the function we're defining is called. So we'll just say temperature reading and say that this is a transaction. So now we can come down and say function, and then we'll just copy this for clarity, temperature reading, because that's what our function's called, and we'll pass in the results of it. Okay, so we're ready to go. Now, for this temperature reading, we're not going to be creating anything new. We're just going to be updating existing assets within our network. So if you recall, we actually have to go over to our model file again, because before we defined this transaction, I had commented out this little piece of the shipment. So we had temperature readings. These are this refers to the transaction that we're creating on each shipment, and we can have as many of them as we want. So if we come over to the playground and uncomment this same thing, so let's go ahead and uncomment that, and also we need to update with these. So let's copy our definitions we just created, put them at the bottom. Everything looks good, and we'll update it. And if you remember, if we come over to test and we click on the shipments, there should be temperature readings on here. So if we create a new asset and click optional properties, you can see that there are temperature readings. And by default, when this transaction executes, this temperature readings field will be populated by the temperature readings. So we'll go back to the function and we'll start writing it. So in this function, we have to define what shipment we're talking about. So when we do the temperature reading, we have to declare, okay, we're gonna do a temperature reading on, shipment number 1. So in the composer playground over here, our ID for this one is ship 001. So that's what we're looking for. So we'll set the shipment variable equal to temperature reading dot shipment. So what does that mean? Well, by default, what we just defined in the model file, we said that each temperature reading transaction is going to have a relationship to a particular shipment. So if this particular transaction is called temperature reading, it has a property called .shipment, which refers to the particular shipment that we're doing a temperature reading on. Now we're going to, for clarity, this is what the example already has in here. So we're going to console.log adding a temperature of, and then we'll say our temperature reading dot centigrade plus to shipment. And if you recall, the temperature reading dot centigrade, we also have this property on each temperature reading, so that can be referred to as a number. Now we're going to come down and just execute a little bit of logic. So we'll say if shipment, which refers to the shipment that we are doing the temperature reading on. So if shipment.temperature readings, and if you recall, that refers to, remember, if we created a new shipment and went to the optional properties, that includes the array of temperature readings that we already have. So we're saying if there are temperature readings already on this shipment, what we're going to do is we're going to say shipment.temperature readings push the temperature reading that we are doing right now. So if there are already shipment readings, we're going to .push or append to the existing array the temperature reading that we're doing right now. Otherwise, if there's no readings already, we have to create a reading. So we'll say shipment.temperature readings equals an array that contains just the current temperature reading that we're doing. Okay, so that logic right there is going to append temperature readings to this field right here. See this empty array? That logic will append to that array. And then finally, we're going to return. And if you remember, we have this method called getAssetRegistry. And if we specify org.acme.shipping.perishable and shipment, the shipment like class basically, and then we can execute a .then method on this, and we'll pass in the result of that registry search. So we've searched for all the shipments, and we've been given a shipment registry which contains all of those shipments. Now with that shipment registry, what we want to do is update the particular shipment that we're doing the temperature reading on. The way we do that is by using the method update participant. So we'll say return shipment registry. Remember, we just got that from this first return of getAssetRegistry. So we'll return shipment registry dot update, and we're going to pass in the shipment that we defined right up here and that we altered right here with this logic. Okay, so that should take care of this function, and now we should be able to do a temperature reading. So let's go ahead and save this, and then we'll copy this logic that we did over to the playground. So we'll go to the Define tab, to the script file, and at the end we'll copy that in. It's telling me that everything looks good, so hopefully we didn't make any mistakes. Let's make sure, I believe, yes, we did add the relevant transaction in the model file. So now if we go over to test and we want to submit a temperature reading on contract 001, you're going to see that now, or I apologize, not contract. If we go to shipment 001, you're going to see right now we don't have any temperature readings on it, but once we submit the temperature reading transaction, we'll give it a temperature rating of 8, and we'll refer to ship ID of ship 001. Submit that, and you can see that this shipment just updated. We just appended a new temperature reading which contained a centigrade and also the shipment that it refers to. You can also see that there's a transaction ID and a timestamp on this temperature reading. And if you recall, I had talked a little bit about that timestamp right here. So when we created our setup demo, we had specified the arrival date time, and I had talked about how each transaction has a built-in timestamp on it, and I'm guessing it also has a built-in transaction ID as well. So the last smart contract that we're going to create with this JavaScript API is the one that determines where the funds will go upon the arrival of a shipment. So at this point, what we've done is put a temperature reading on this shipment 001, and we've given it a centigrade of 8. Now, if you remember on the contract asset, we can define a minimum and a maximum temperature. And we also have defined a unit price and some penalty factors. And also, it determines which participants are part of the contract. So we want a piece of logic that upon the arrival of a particular shipment, we'll say shipment 001, it's going to, the code itself is going to check these temperature readings, make sure that the temperature is within the bounds, and then properly allocate the funds from one participant to another. So I believe the built-in logic, or the logic that was in this example network, said that upon the arrival of a shipment, the grower receives funds from the importer, and I don't think the shipper has anything happen in terms of their bank account. So anyways, we'll get back to the code and write that out. So again, we have to first define the transaction within the model file. So we'll come to perishable.cto and define one more transaction. And we'll call this transaction, I believe what they call, we'll say shipment received, which extends our shipment transaction as well. But we don't have to do anything with this like we did here with the centigrade. All we have to do is provide it what we have in our abstract transaction. We just have to tell the contract which shipment that we're saying has been received. So we'll save that, and then we have to come over to our logic.js and define at the bottom a new comment, and we'll say this as a description. We'll say a shipment has been received and funds need to be allocated. And then this is where the important part comes in. We'll say at param, give it the namespace or the target that we are looking for. So org.acme.shipping.perishable, and we are targeting a contract or a transaction called shipment received. So we can copy this, copy that over, and give it that. And then we'll call our function shipment received as well. So I believe that's all we have to do there. And then we say at transaction to let it know it's a transaction. Now we can come down and define a function called shipment received. We'll pass in the same parameter. So this is the individual transaction as an argument. So now we can start defining the logic behind this contract. So we need 3 variables. We need a contract, we need a shipment, and we need a money, which refers to how much money is going to be paid from one party to another. So in order to get these 3 variables, we can say shipment received, which again is right here and refers to the transaction that we're executing. So with that shipment received, we should have a shipment that we're referring to, and then on that shipment we should have a contract that that shipment is referring to. So I'll take you through that real quick because that's a little bit confusing. But the actual shipment transaction, or the shipment received transaction, should refer to a particular shipment, so maybe ship 001, and then the ship 001 has a contract that it refers to, which is contract 001. So that's what we did right there. We just said we want the transaction, and then the shipment that is relevant to that transaction, and then the contract that is relevant to that shipment. And then the shipment is similar, so we just say we'll leave it at .shipment. And then the money is going to be the contract. So we've defined the contract variable. So contract dot unit price. If you can remember, each contract has a unit price property on it. So that's what we just targeted there. We're going to say the unit price times the shipment right here dot unit count. So you can also remember that the shipment has a unit count, and so we have 5,000 bananas in this shipment. So that is the money, assuming that there are no penalties at all. Now, if you recall, each shipment has to be received within a, I believe, 1-day time period. I think that's what we said, yeah, tomorrow.getDate +1. So within a 1-day time period, and if it is not received, then it's free or something like that. I don't really know the logic behind that, but that's what we were given. So let's go ahead and console.log just so that we know what's going on. We'll say that this shipment received, or this shipment was received at, and then we can define that by the shipment received, so we're talking about the transaction itself, and give it the built-in timestamp property that we had talked about. So that's going to tell us when the shipment is received, and then we can say the contract arrival date time, so the required arrival date time that we needed to get this shipment in by was contract dot arrival date time. And then we can come down and, well, first we need to say the shipment status equals arrived because it was previously in transit. You can see that, I believe, right here. So the status was in transit. We need to set that to arrived. And then we need to check to make sure it was on time. So we're going to target the transaction timestamp. And we'll say if that is greater than, or basically if the actual received date is later than the stipulated arrival time on the contract, then we're going to say money equals 0 because the grower should not be paid for a super late shipment. And we'll say console.log late shipment, no money received by grower. Okay, now under the assumption that it was received on time, we have a little bit different logic here. So if it's received on time, then we have to find the temperature readings within this shipment. So we'll say if there are temperature readings on the shipment, remember what we're targeting here is the temperature readings property, and that is an array. So if there is at least one in the array, what we're going to say, what we need to do is actually get the lowest and the highest temp reading. And the way we do that is just with some built-in JavaScript functionality. So we'll say shipment dot temperature readings dot sort, and we're going to sort defined by this logic. So we're going to sort it by the centigrade. So what we're doing here is getting the lowest temperature reading at the very beginning of the array and the highest temperature reading at the end of the array. So that's what that does right there. So now we can say that the lowest reading equals the first item in this temperature readings array. Okay, and then we can say the highest reading, conversely, equals the last element in this array. Temperature readings, and then give it a little more logic. So we need the length of this array subtracted by 1 because we're 0 indexing. Okay, so that should give us the lowest and the highest reading. And we're going to say the penalty equals 0 right now, but that could be updated. So we'll say, we'll console.log out into the console. The lowest temp reading is, and we're just going to give it the lowest reading variable. Or actually, the lowest reading right here refers to the entire object here, but we need to access the centigrade property to get the actual temperature reading. So we'll say lowest reading dot centigrade, and we'll do that. We'll do the same thing, just copy it down, and we'll say highest reading dot centigrade and change that to highest temp reading. Okay, so we know what the lowest and the highest temperature readings are, and then now we're going to put the main logic behind this in. So we'll say if the lowest reading temperature, or dot centigrade, is less than the contract minimum temperature, then we need to update the penalty factor to reflect the minimum temperature penalty factor written in on the contract. And we're going to do that. The penalty is kind of in terms of a price. So we're going to say, how many degrees under were we? And we're going to multiply that by the minimum penalty factor. And that's going to be the price penalty so far. Okay, so we'll say that the price penalty, the min temp price penalty, is the penalty variable. So we'll say if highest reading dot centigrade is greater than the contract's max temperature, likewise we're going to update the penalty price, the price penalty, to reflect this, however much we went over. And we're going to print that out to the console. Max temp price penalty. And we'll give that the penalty. So realistically, we could actually have 2 penalties within this price. So now we have to apply the penalties to the price itself. So money is going to be subtracted by whatever the penalty that we have calculated times the amount of units in the shipment. So that should calculate everything out correctly, and we'll say, under the case that we had so many penalties that it actually drove the price on the shipment below 0, we have to account for that. So if money is less than 0, then we're just going to set money equal to 0 so that we can never have a negative payout. So I believe that does it for this part of the logic. And now we have to come down here and finish it out. So console.log will say money received was money variable. And now we're going to say the contract, and this is what, actually I should probably describe what we're doing here. So update account balances appropriately. So the way we do that is, if you remember, we have up at the top of our function the contract, the shipment objects here. So we can say the grower on the contract, we're going to update that grower's account balance by the money. And then we're going to say the importer, we're going to update their account balance. We're going to subtract off the money. And so that should do it. And now all we have to do is update the registries. So just like we've done in the previous two functions, we have to return a promise, and we have to get the participant registry, give it the namespace that we're looking for. We're looking for the grower at first, at least. So what we're passing in is the registry of growers here. And this is only because we have updated the grower's account balance. So we updated it right here. So we have to basically commit that to the network here. So we're going to return grower registry dot update. We've seen this before, and we're updating the contract dot grower. And you can see here that we have finished our function. So all we did in these last several lines of code was what we had done before. We're just taking all of the changes that we made up here to different assets and participants, and we're essentially committing those to the network. And throughout this function, all this function did was we changed the shipment status to arrived, because that's the whole point of this function. And then based on the temperature readings, as well as the timestamp on the shipment, we allocated different payouts to the different players that are involved with this shipment. So let's go ahead and copy this over to the playground. Hopefully we didn't make any mistakes. So we'll go to the script file, put this here at the bottom. It's showing me that we have an error. So the error that we're finding is just the fact that we have not defined this in our model file yet. So we have to come over and copy this transaction, go to the model file, and paste that in there at the very bottom. Update our model file, come back to our script file, and we'll see if we do not have it. So let's go back to the editor, copy our function once more, and put this at the bottom, and everything should be fine now. So we can go over to our test tab, and if we remember, we had a shipment called ship001 that had one temperature reading, that had a temperature reading of 8, and based on the contract that we had used for this shipment, which is contract 01, that's within the temperature bounds. So we should get a payout of the unit price of 0.5 times the unit count of 5,000, assuming that we made this shipment on time. So we'll look at the grower. The grower that we had on this shipment was, or the contract, was just the farmer, and then the importer was the supermarket at email.com. So if we go over to the farmer at email.com, you can see their account balance is 0. And the importer, supermarket at email.com, their account balance is 0. So we need to give them some money to pay. So we'll update that first. And now we'll try to submit our shipment received transaction and designate ship001. And we can see that this importer has decreased their account balance by the appropriate amount, so 2,500, and the grower should now have 2,500 in their account. Finally, the shipment itself should say arrived here, and our transaction has worked correctly. So the last thing that I wanted to show you in this tutorial on the JavaScript API is just how we might go about our permissioning language to this whole deal. So if we come over to the Define tab again, and we go to the access control file, let's add a rule at the top. So what if we said that we're not going to allow the grower himself to register or to submit a temperature reading for whatever reason? So all we would have to do is say, create a rule that says grower temp reading. And we'll give it a description that says grower cannot submit temp readings. We're going to target that grower participant by saying org.acme.shipping.perishable.grower. We're going to say that the operations that this participant cannot perform is all of them on the resource defined by org.acme.shipping.perishable.temperature reading. And we're going to say the action is deny. So remember, we put this at the top of our permissions file so that it actually goes into effect, and we'll update that. We'll come up to, well, first let's look at our participants. So since we're targeting the grower, we'll just take farmer 3 for example. So farmer 3 is the identity we're going to issue. So we'll come up to the ID registry, issue a new ID, call this person Bob, and we'll say farmer3 at email.com is the identity we're issuing to. So we'll create this new, and now we're going to say we're going to use this person named Bob on our network. So based on our permissions file, Bob should not be able to submit this temperature reading transaction that we just created. So if we submit transaction in a temperature reading, we'll just say that this temperature reading is on ship 002 and give it something like 5, and we'll press submit, but it says down here that this participant does not have create access to this transaction. So right there you can see exactly how these transactions that we just coded with the JavaScript API, they are just as applicable to these permissions rules as anything else, any asset within this network as well. So hopefully this brought things full scale, and in the final development tutorial of this series, I'll go into the basics of creating an Angular application that incorporates everything that we've learned so far into hopefully a user interface that someone who doesn't know how to use this network can use. So I hope you learned a lot in this tutorial, and feel free to leave any comments in the comments section. Thanks.